Hello. Next we will have a quiz. If you use laptop, please close your laptop, and you to close and you also cannot use tablet. And if you need to use answer sheets, please raise your hand. The first question is to determine the array size and the string length of the following character array. Uh, 30 seconds left. Then I will turn on the second question. The second question is to determine the value of name of the above statements. 30 seconds left. Next, I turn on the third question. You need to password is an integer array, and you need to determine the values in this integer array. Uh, 30 seconds left. And I will turn off all the questions. If you use answer sheets, remember to write down your name and student ID. And please turn in your answer sheets. Let's see the answers to the quiz. The answer is option 4. So this is a character array, and we first we can determine the string length. The string length is the number of characters inside this double quote. So PROG are four characters, and the space is 1 character. Class is contains 5 characters, so this is 10. And the \n is 1 character. So this is known as escape sequence. So \n is 1 character. So inside the quotes are 11 characters. So the string length is 11. And the array size also need to include the null character because this is a C string. If we use double quotes, then this means this is a C string. And every C string is ended with the null character. So we need to include the size of the null character. So array size is string length plus 1. So you can try to do some experiments. So array size is 12 bytes, and string length is 11. The second question is the statements will lead to syntax error. We see that in this statement we have two plus, and the left plus will be carried out first. So first the compiler will evaluate this expression. And name1, we know that the data type of name1 is character array. So for character array, we do not have the plus operator does not support character array. So you cannot use this expression. This will lead to syntax error. So you see that for the binary operator plus, this operator does not support you to operate on character arrays. If you change the data type, for example, if you change data type to C++ string, then the first plus is legal because C++ string support the plus operator. So if you use C++ string, then C++ string support plus operator. However, if you use if both operands are C string, then you cannot use plus. the answer of the third question is option 1. Let's see this question. We need to determine the values in this integer array, and each element is set to dictionary at the index I minus character A. So we need to perform this expression. So each element in this dictionary is a character. So we perform character D minus character A, and we know that each character represents one integer. So we can perform subtraction. So we can perform character D minus character A. So if you perform character D minus character A, then you obtain 3. So the difference is the index difference between D and A. So if you perform character D minus character A, then you obtain 3. And therefore, and then you can continue this. You can continue to compute every element. Then we obtain the values inside this array is option 1. If no further questions about the quiz, then I will return to the slides. Next, I will introduce pick and putback and the get. And let's watch a video. This video is in. We have a reference web page, and you can go to this page. And you can find under the strings chapter, you can find this link. And this link is a YouTube video introduce get, putback, and pick function.
Hello, this is Robert, and in this video I would like to demonstrate how cn.get, cn.peek, and cn.putback work. I've set up this little demonstration inside of a graphics program so that I can represent what's going on graphically. So I've set up a stream buffer here, and this is controlled by the operating system. And so when the user types letters on the keyboard, the operating system keeps track of which letters are typed using a stream buffer. And you can see that the characters are filled in from left to right in this example. And so let's say that the user types A first, so that would be stored right there. And then they type a B. And then they type a C on the keyboard, and then let's say they type return. Okay, so when our program starts up, let's say that these are the first few statements in our program. So we set aside memory for ch1, which is a char. There it is right there. Then we set aside memory for another char called ch2, and there it is right there. So when we reach this first cn.get statement, that will remove the first character from the buffer and store it at memory location ch1. So the A goes from the buffer into ch1. And then what happens is the next character to be read moves over to the next byte. right there. So when we have the next statement, cn.get ch2, B will be read from the buffer and stored into ch2, and then the pointer for the stream buffer, the next item to be read, will move over to C. If this is the end of our program, then the C will be thrown out. Otherwise, if there was another cn.get statement in our program, then the C would be read. Okay, so it's stored for further input, regardless. And if the program terminates, then it's thrown away. Okay, so let's reset our program so that the user has typed A first, and then B second, and then C. So the first thing to be read will be A. But let's change our program, and we're not going to be using just simply get anymore. Let's use a combination of several statements. Okay, so we still set aside ch1 and ch2 right there. But the first statement to be executed is cn.peak. Okay, so peak is very similar to get, except that it will not move the pointer over to read the next item. Remember that that's what we did with get. With peak, we still will read the character from the buffer into ch1, and so we'll grab the A, but this time it's not removed from the stream buffer. So we did make a copy of the A to store it in ch1, but we didn't move over to read the B next. Okay, so with peak, we are still going to read the memory from the buffer. So the A went from the buffer up to ch1, but then the pointer stayed at A. So A was not removed from the buffer, and it will be the next thing to be read. Incidentally, notice that cn.peak uses a different style. With get, we have the character to be read inside of the parentheses right there. With peak, we can't do that. With peak, we have to use an assignment statement and actually store it to the left side of that assignment statement. You're not allowed to put any characters inside of the parentheses with peak. You'll get a syntax error. Okay, now that we have peaked and we've loaded the first character into ch1, now we will move on to the next statement right here. And so cn.get ch2. Well, the pointer is pointing at A right there, so the A will move into ch2. And then the pointer will move over to read B, right? Because that's how get works. It moves the pointer over to read the next thing. All right. Putback is sort of the opposite of get. And I've just placed a D in here just because it was something different. I could put back ch1, and then that would place an A back in the buffer because that's what ch1 contains. But you're not limited to the thing that you just read. So I just wanted to make that point. I could put back ch2, which would also put back the A, but you can put back into the stream buffer anything you want. So let's go ahead and put back the letter D. So since putback works the same way as get, only in reverse, the first thing we're going to do is we're going to move the pointer back over to the first location in the stream buffer, or the previous location in the stream buffer. And then what we'll do is we will place a D right there in the stream buffer. So we put back a D. So that's how putback works. It's the opposite of get. Remember that get will remove the character from the stream and then move the pointer over. Well, putback is the opposite. So we move the pointer back over to the previous location, and then we store whatever single character we want in that location. And in this example, I'm just putting back a D. So the next statement after putback is cin.get ch2. All right. Well, we grab the D and we place that into ch2. ch2 contained an A, but since we're placing a D there, the A gets clobbered. And so the D is overwritten, or the A is overwritten with D. And then we move the pointer over, and B will be the next thing read. If there is another get statement or some other statement that reads from the buffer. There isn't. Let's just pretend that the program terminates after this statement. Then the B and the C will get thrown away. Okay, I hope that was a good graphical representation of how get, peek, and putback work.
So I think the video is a good introduction about how to use get, peek, and putback. And you can do some experiments. For example, you can copy the code. Here I modify this code. We can use string to store outputs. So here I create a string, a C++ string, and I use this string to record the outputs. And then we print this string. So this string will record the change of ch1 and ch2, and now we can start to enter some inputs. For example, I type ABCD. So here I type ABCD, and then I press enter. And then the program outputs, then the CR will outputs A, B, C, C. And let's see each statement. So we enter ABCD, and for the first get will read character A and save A in ch1, and then the pointer is moved to B. So the next get will read character B and save B in ch2. So str will be AB after the statements. Then we perform cin.peek. Cin.peek will return character C. So ch1 will be character C. But peek is different from get. Peek will not move the pointer, so the pointer remains at a C. So after the peek, the pointer still points to character C. And next, if we use get, so we will get character C, and C is assigned to character 2. So next we update str. So if we print str, then the value of str will be A, B, C, C, and D is not used. So D is discarded because we do not have other get or pick commands. So you can try to run this program or modify this program to learn how to use get or pick. You can also practice how to use putback. Putback is to put one character in a buffer. The next slide is about when we want to read integer and characters. Then you need to deal with the problem of new lines. Then you can write a new line function to process user inputs. And I will skip these slides, so you can because our time is limited. The time is limited, so I will skip this slide. If you are interested, you can run this program by yourself. Below is a self-test exercise in the textbook. And this exercise is about how to use cin.get. First, we read one. We use cin.get to read one character, and then if this character is not the line break, then we enter a while loop. And we also have a integer variable count. Its initial value is 0. And if count is not an even number, then cout will we will print the character. So if count is an even number, then we will output the character. And in each iteration, we increase the value of count by 1. And we also use cin.get to read one character from the user. And we can try to run this program. Now suppose I enter 0 space 1 space 2 space up to 11. Then I press enter. We see that the output is 0, 1, 2, 3, 4, 5 up to 9, and then 1, and then space, and then 1. So this is the program output. And I made a table to explain why the program output like this. The first row is the user input. The user input 0 space 1 space up to 11. So the first row is user input. The second row is the value of count corresponding to the character. So the count corresponding to 0 character is 0. And we know that the space getter can read white space. So ch can be white space. So for the first white space, the corresponding count is 1. And if count is even, then cout will print the character. So here, the character in yellow color will be printed. So the character in yellow the color are 0, 1, 2, 9 up to 9, 1 space and 1. So this is the program output. Next, let's see a related example. This is self-test exercise 18. This exercise is similar to the previous one, except that we modify cin.get. Here we use cin and the double right shift operator to read character. So here we change this statement. We use cin and double right shift to read one character. And then we enter the same inputs. So let's run this program again. I enter the same inputs, and let's see the corresponding outputs. We see that the outputs are different. The outputs are 0, 2, 4, 6, 8, 1, 1. And let's see the explanation. I also made a table for this example. The first row is user inputs. So the user input is 0 space 1 space. And the second row is the corresponding value of count. And we know that cin double right shift does not read white space. So here space does not have corresponding count because ch will not be a white space. So here the white space does not have a corresponding count. And well, we only output when count is even. When count is even, we output the character. So here, when count is even, we output the corresponding ch. So the ch in yellow color will be output in the screen. So the output is 0, 2, 4, 6, 8, 1, 1. So the program output is this line. And at the end of these slides are some questions for you to revisit what we have learned. The first question is to determine the number of characters in each sub-question. So for the first one, this is single quote. So, and this is the backslash n. So the first the first one only has one character. While for the second one use a double quote. Double quote means C string, and the C string is ended with the null character. So the second expression has two characters, \n and the null character. And the third, and this one is also a C string because we use double quote. So this C string is equivalent to a character array with 5 characters. You can refer to the slides. If when we write this expression, this is equivalent to we initialize using a pair of braces. For this expression has 5 plus 1. So this expression has 6 characters. For Q2, we need to determine which declarations are equivalent. And previously, we already know the first 2 are equivalent. So this C string is a shorthand notation for the second expression. So str1 and str2 are equivalent. But str3 is different because the array size of str3 is 5, while the array size of str2 is 6. So str3 is different from the previous 2. And the next question is similar to the previous one, with one difference. Here we do not specify array size. The array size is determined by the right-hand side. But for Q3, we specify the array size. The array size is set to 10. And we also use the right-hand side to initialize this character array. And you need to determine which statements are equivalent. If you think all the statements are equivalent, please raise your hand if you think all the statements are equivalent. Okay, and if you think some statements are not equivalent, please raise your hand. Okay. Okay, and let's see. And the answer is the first one. All the three statements are equivalent. I will explain why. This is because the array size are the same. The array size are 10. On the right hand side, here we only specify 6 characters, and the remaining 4 elements will be set to 0. This is according to the C++ rule. So the remaining 4 elements will be set to 0. And we also know that 0 is equivalent to the null character. So uh, if you check the ASCII value of the null character, so the decimal value of the null character is 0. So the remaining 4 characters will be set to 0. And this is the same as so str3 is the same. The remaining on the right hand side are 5 characters, and the remaining 5 characters will be set to 0. And actually, you can try to print this character array to know whether they are equivalent. Here I will perform typecasting because the null character is invisible. So I convert to integer, so we can see its integer value. So here I print the values in the 3 character array. And we will see that the three characters are the same. The last 5 elements are 0. I think time is up, so we can have a break for 10 minutes.